Everyone, welcome to our webinar. My name is Anna Strogins, and I'm a lecturer in Management Science Department at Lancaster University in England. And I'm a part of International Institute of for Forecasters and Early Career Researchers group there. And actually, we call it Early Career Forecasters now. Today we are going to have a webinar Beyond the Hype and Exploring the Use of Large Language Models by Philotas Theodoris. Sorry. I will quickly introduce our team and talk about what we do and how, what is our main purpose. We are Early Career Forecasters Group under IAF Institute, and we have a few members from different countries at different sort of stages in their early career. We organize different events and especially during ICF International Symposium on Forecasting. So if you're curious about forecasting or you have any interest in that direction, we have an amazing symposium, and the next one will be in Dijon in France. And there was actually a call for abstract now, and I think the deadline is somewhere in March. So you could have a look at IAF website for the details. And please do join if you can and you want, because this is, again, amazing community, really welcoming and sharing different ideas, different research things. And we have plenty of practitioners joining as well. So hence, you can observe research and practice at the same time. I think this is one of the main things that I want to briefly introduce today. So our team is always growing, and you might have noticed that we have a few assistant professors already in our group, and one professor even, Niels Pereira. Congratulations to Niels on that. We are looking for new blood to our group. So if you're early career forecaster and you're passionate about forecasting, you want to make an impact, you want to join the community of young forecasters and actually organize some interesting events, please do reach out and join our team. I would say we are quite welcoming and kind, and we learn a lot from each other. So that could be useful on its own, but also it's of course it's good for your CV, for your experience, and so on. So again, if you considered something like this, please do reach out and talk to us. And yeah, we will be really happy to have new members in our organizing team. And one more thing, this is just a voluntary participation. So basically, you're not forced to do anything, but at the same time, we're all passionate about this group. And of course, there is a bit on webinar etiquette. I'm sure majority of you know this. Just a few notes. This webinar will be recorded and will be uploaded later on to IAF YouTube channel. So hopefully everyone is okay with that. It's really useful, and I got also several emails that they can't attend now, but they will be really happy to watch it later. So that's the idea. And also you can follow us on LinkedIn. Again, check our IAF YouTube channel for other seminars and webinars that we had. And also we have run some activities during ISF, as I said that before. So have a look at these different activities that we try to organize. But the main idea for today is actually our webinar about large language models, and I'm really excited about this topic because I want to learn more about those models, and in particular ChatGPT, and how to use it. And the first thing that when I thought about this topic, Philotas came to mind straight away, and I thought that he's so passionate about LLMs and ChatGPT, and he knows so much comparing to me that I thought that he's a great speaker for that. And also he's ECR, so yeah, listening some case uses or some bits that other ECRs are using, that's always useful. So yeah, this is all for me. So hopefully you will enjoy this webinar with me. Philotas, we'll stop sharing now. And if you could share your screen, that would be great.
Does that work, Anna?
Yes.
Okay,
yes.
Great. Very good. Well, hello people. Thank you for the introduction, Anna. And thank you for the work you are doing with the community. All of you people with early career forecasters, you have helped me in the past, very helpful. So I'm Philotas Theodosiou. I'm a research associate at Vives University of Applied Sciences in Belgium. We mainly work with demand forecasting. We assist our partners improving their forecasting processes. We also work with applying AI in other domains like education and enhancing teacher-student collaboration. And we recently started a new project on applying artificial intelligence to reduce food waste in Flanders in Belgium. As Anna said, on my free time, I really enjoy reading about AI and LLMs. So this talk is about the knowledge I have communicated all this time. So I hope you enjoy. Okay, let's start right. Does that work? Yeah, okay. So we're reaching the end of 2023, and I know you have heard a lot of AI. And if you haven't heard the word yet, I'm gonna give you some examples. So you go on the news, and the news is going crazy. AI will transform every industry we know. It's gonna be used everywhere. It's everywhere. Notable words in 2023: help with climate change. Chinese influencers are using AI. We're using it in our work environments. It can help contract negotiation. There was the drama with OpenAI and the CEO change. It can create, you can help in the elections. Even Pope was in the AI talk. So things got serious. What's with all these news articles is they have some kind of hype, and the question that gets in my mind most of the times is AI just hype, or is it actually something that is relevant? And to answer this question, this is the McKinsey State of the AI report on the industry, how industry sees AI, and in the survey took 1/3 of the participants uses generative AI. So this is a word a phrase, I'm gonna use throughout the presentation. I'm gonna explain later what it is. So 1/3 of participants in the McKinsey report said they are using generative AI, and almost 88% almost 88% of organizations that use AI are implementing generative AI, or they are planning to use. And I know this word might not be so familiar. So it's a new trend in the AI field. It's a recent trend on the last years. What it is, you can view the layers of artificial intelligence here. I'm not adding definitions. I don't like broad definitions because people tend to stick to words. So you can choose your definition. So artificial intelligence can be the intelligent machine learning. I'm just gonna say learn patterns from data. Then we have deep learning, which broadly speaking, it's neural networks. And we're familiar with deep learning by now. And generative AI is a subfield of deep learning. which is composed of neural networks that are trained to produce images and text. So we mainly have LLMs. We used to have GANs, generative adversarial neural networks. Now we have stable diffusion, but it's mainly LLMs and stable diffusion. So these models are trained to model a distribution of images or text or audio or a multimodal distribution of everything. And then we sample from this distribution and we generate new or not new text. That's an open discussion. So LLMs are what drive the AI hype. So, and it has, thanks to them, AI has got the attention of pretty much everyone, I would say. And this is a text from my mother some time ago. So she's not familiar with the topic, but she read in the news that AI will bring the end of the world. So she was scared. Like everyone is familiar of AI by now. And in my opinion, this started like a year ago with the release of ChatGPT. So it was the pivotal moment, and it skyrocketed the popularity of AI. Why? The answer, in my opinion, is natural language. It's a very easy framework to communicate with this and interact with these models. So you chat, you ask questions, they answer, you ask again. It's very natural and very easy for people to use that. So it's available to everyone. Everyone can chat on their laptop or on their phone. However, even if many people use them, a few of them, not a few, but not a lot of people understand how they actually work. And this is the case even for AI related roles, which of course is not weird because the field is huge and there are so many models and so many techniques and so many applications, which is impossible to know everything. But what is weird to me and what I find surprising is that people assume that this is a work of the last 2 years or something that has happened magically from one night to the other. And actually, on the latest machine learning conference, NeurIPS, they rewarded the best paper, which was the embeddings paper, the work to vec paper that came back in 2012. So this is, which is the backbone of large language models. So this is cumulative research of many decades until we reach that point. It's not something trivial, so it's not weird that people do not know how these things work. And as with everything that is super hyped in our world, there's always super criticism. And this is some of the most important critical points I've come up. LLMs are just statistics. They are useless parrots. They create false information by hallucinating. They cannot reason. They cannot generalize. They are biased. They promote misinformation. They are not transparent. They lack contextual awareness, and they are not environmental costly. Of course, many more to come. And to be honest, in my opinion, I agree with almost all of this. Maybe all of this, but I will say almost all of this. But I believe we look at it in a completely different way, because all this hard skepticism makes the use of the models, we forget how useful they are and we focus on the skepticism. And for example, in forecasting, you know that an ETS model has limitations, but it's still a super good model that we use all the time. So we know the limitations, but we still use it. So this is my idea behind LLMs. And after that, there's evidence for their impact. They boost productivity of workers, which I can verify, both in speed and quality of not only writing tasks, but tasks in general. They have positive impact on teaching learning processes. When it comes to coding, they lead to more task completions and especially faster. They have integrated in learning platforms like Duolingo and Khan Academy. You can use some of them for, well, you can, but not suggested for health-related questions. And FunSearch is a new LLM that solves an open problem in mathematics pretty recently. It's published in Nature like a week ago. So yeah, there is evidence of their impact. And given the skepticism and the impact is what actually inspired me for that talk, to get a middle ground. And to get there, we need to think about what is common in the findings, on all the previous findings, is that LLMs, it's not magic. It's not something that does super fancy things on their own. All the success comes from the collaboration between humans and LLMs. They don't do everything together, and they don't do everything alone, and we don't do everything alone. we collaborate, and we get productivity boosts. And that's the main idea to give. This is what inspired the outline of this talk. So what I'm going to talk about, I'm going to briefly try to explain how they work, give some example of use cases, some pitfalls and suggestions on how to use them right, and then I'm going to summarize the whole talk. Okay, let's start with how they begin, how they work. First question, and the simplest one, what is a large language model? So a large language model is a very deep neural network, very deep neural network. It has weights, it has biases, it has parameters, it is trained on an objective, and it has a training set. Neural networks as we know them. Its objective is to auto-regressively predict the next word in a sequence. So you have text, cat, sat, ton, ne, and there is a probabilistic output that says 97% of the time, yeah, maybe math is the right question. So this is what they do. It's a classification problem on a lot of tokens, and they are trained to auto-regressively predict which token is the most probable to follow the previous words in the segments. And as with all neural networks, we need data. So data for large language models is a huge chunk of the internet. Some claim that it's the whole internet. I don't believe it, but it's something they claim. So it's a big chunk of the internet. Everything that is text out there, from Wikipedia to books to Amazon reviews, everything you can picture. Unfortunately, nowadays, most closed source models do not share details for their datasets. But the idea is, imagine terabytes of text being gathered, and this text is being fed into highly specialized GPU clusters, which are specifically designed to train large language models, because this task is extremely costly, and even small mistakes can lead to big expenses, something that, of course, companies do not want, and associations in general. So you take the text, you feed them into a big computer, big cluster of computers with many highly specialized GPUs, and you train the neural network. So in some sense, how I like to picture it is that training large language models is actually a loose compression of all the text in the model parameters. So you take all the chunk of the internet and you try to compress it into some billion parameters or trillions. And the question that comes is, is next word prediction sufficient? Is what it will lead to intelligence that might surpass humans in the future? According to one of the most influential researchers in AI, LLMs learn a representation of the world we live. In my very honest opinion, I don't like this definition a lot, but there is some value on it, because in order to predict the next word, you need to have some information about this word. So for example, when you ask who is Alan Turing, it needs to know what is a mathematician, what is artificial intelligence, what is World War II, who fought in the World War II, what is Enigma. So in order to get this text out, it needs to have some understanding of a lot of text. That's how I like to picture it. So it's a sample of text describing some parts of the world compressed in the parameters. How do they work? Good question. To be honest, people don't know. No one knows at the moment. We know that it's a transformer-based architecture, the same from 2017. People are working on how they work. In some sense, we have billions of parameters that collaborate to make a prediction. We know that if we adjust some of these parameters, predictions get better. But we don't know how they collaborate and how to optimally adjust them. This is why it's a black box model. Again, in some sense, they built a knowledge database, but this knowledge database in the parameters are very weird and imperfect. And this is a very known problem, the reversal curse. So who's Tom Cruise's mother? Mary Lee Pfeiffer. Who is Mary Lee Pfeiffer's son? We don't know. So this is one of the limitations of these models. The way they compressed knowledge is not yet fully understood. How to train these models? We start with pre-training. It was what we described before. You take a lot of text and you feed it, so the model learns to mimic. It actually builds this training distribution of the text that we have collected, And if you ask for some knowledge on Wikipedia-like knowledge, it would generate a Wikipedia-like output. If you ask for transactions, it will generate an Amazon transaction form. However, this is not helpful. We don't want a document generator. We want an assistant. We want to ask questions and get answers. And that leads us to the second training phase, which is fine-tuning. So we keep the same training process, again, auto-regressively output the next token, but we change the training set. Instead of training on the whole internet, which contains a lot of noise, we compose very specialized training instances in this format. So you have a user input and you get an output. These are written by humans. Human labels compose these documents. So they write this user input and what they expect as an output. And they give that to the model. So the model is fine-tuned to answer in this way. And this was the norm until around summer 2022, a bit before ChatGPT. So you ask the user, you ask the model like that, and you got an output. It was still useful. People were still using it, but it was kind of limited. And it was not able to scale because human labels are expensive, and scaling them, these models in this way, having a lot of people make all these documents is not easy. It's hard. It costs a lot of money and it's not optimal. And then came the $1 million idea that changed LLMs. What if we use AI to build the data set? And instead of humans actually writing the documents, AI writes the documents, and humans do what they are very good at and what we are very much better than LLMs, decide if something is good. So for this same prompt, you generate different samples and you have a human deciding which one of these two is better. So instead of writing this thing in, I don't know, 10 minutes to write this document, you just decide in one click which one is better, and you tell the model, okay, generate more like this, not like this. And this is what unlocked the potential of ChatGPT. This is called reinforcement learning with human feedback. It's described in the paper from OpenAI. It's the last step in training large language models. So you sample from a distribution of documents in this format. You sample a lot of documents. You make the model sample a lot of them. You have a human labeler ranking them. So output D was better than C, was better than A, was better than B, and so on. And then you train a reinforcement learning algorithm. It's Q-learning. Inventory crowd might be familiar with Q-learning reinforcement, with a Q-learning algorithm. It's the same exact form. The reinforcement learning tries to produce the best output that will give the highest reward according to what the human labelers did. And this is how ChatGPT was born. It was trained on a lot of these outputs, and it was able, every time you give an input prompt, it will generate what will maximize its reward. That's how they chat. All right, that's with how they work. To summarize, it's a transformer. It's trained on 3 stages: pre-training, fine-tuning, reinforcement learning with human feedback. What we understand is that it compresses text in the parameters in a way that we don't understand. And what we are doing then is we are trying to instruct it to align its behavior on our needs. For example, if I want to have a travel assistant that will help me when I'm traveling, I can add more documents that are related to traveling, and I can have my travel assistant by repeating, fine-tuning, and reinforcement learning with human feedback. Pre-training is the most costly step, and it's staying the same. And it is the current status of large language models landscape. We have a zoo of models at the moment. We have open models that are open source. We have closed source models like ChatGPT and so on. We have models that have limited number of parameters and you can run them on your laptop or on your phone locally. We have models that are huge and it requires gigabytes of RAM to run. So you can only run them on cloud. You have models that is cheap to make predictions and models that are expensive. Nowadays, they can access tools, they can code, they can create images. You have DALL-E 2, Midjourney, all these models. They can access the internet with Bing. They can read the news. It's Grok from Twitter. It has access to latest tweets. And of course, there are evaluation metrics, which one is better, and so on. As with all models, there are evaluations. Actually, this is from Chatbot Arena, where it's a kind of an arena where you go and you type a prompt, and every model generates an output, and people rank which output was better. It's the most realistic and human-based evaluation that we have. All right. That's with large language model and how they work. Let's see how we use them in practice. First question, when do you use? I have a rule of thumb. People do the mistake to use them on tasks they don't know the answer, which is the most important, important limitation and what's to avoid at all costs. You should never use them on something that you do not know the solution. You will probably end up with you might end up with something that is not true. Instead, I like to use them on tasks that I know the solution, that I know something is correct, but it's very cognitive intensive to reach that solution. And let me give you an example. So let's assume I like poetry, but I'm very bad at writing poems, but I know which poems I like. So what I can do is I can ask ChatGPT, okay, you know what? Write me a poem about something, about drinking a beer in a pub in London, thinking about how to make my model work. It generates output, and I can judge which one of these I like. But I could not come up with the actual poem. It would take me, I don't know, hours, maybe days to even get 3 lines. So I get this in, I don't know, 1 minute, and I can choose whichever I want. So my rule of thumb is use it when you can decide if the solution is correct, but it's very hard to actually reach the solution, and not on something that you do not know. And I'm going to elaborate on that. Let's say you want to write an abstract or a paragraph, and you have the example for this talk. So Anne asked me to write an abstract and give a title. So what many people do when they have a task and want to accomplish is they go to ChatGPT and they're like, okay, I am doing that, write an abstract and give a talk and title to my talk. And they expect some sort of magic, some sort of artificial super intelligence that an AI knows everything about you and everything about your talk, and it will create a perfect abstract, which of course is not the case. It will create something that is completely off of what you were expecting, with many fancy words, out of topic, and no structure. And they will get demotivated. They will say, okay, these models do not work, which of course they do not work, because in some sense, you need to use them right. You need to use this technology right. So this is the most typical mistake, going on the wild and asking this to create a title and an abstract. In my experience, and I've been using this intensively for the last year and more, it never works like that. What you should do instead is, this is how I would do it. This is how, it's collaboration. You are always in control. We work together, me and the large language model. It generates solutions. I'm evaluating them and I am adjusting them, and then I'm reprompting it to create a new prompt. Let's see the example. So again, I have a structure for my talk, which is this talk. This is what I'm gonna talk with. And to begin with, I need to have a title and a small abstract. And I'm taking it step by step. I'm not asking, okay, create everything at once. Let's start with the title. Let's create an abstract umbrella term that will cover my whole talk. So I'm saying, okay, give me 5 to 10 alternatives. Why? Because I can compare different outcomes, and I can take the best of every alternative and I can create a title. And this is what happened. It created 10 titles for me based on the structure that I gave. I took the words that I liked from every output: beyond the hype, exploring the use. I kept the researchers. It says ChatGPT. I changed it to large language models to generalize, and this is how the title was created. And then we go to the abstract. I use the following methodology. I use the same methodology as with the titles. You take it step by step, and you build a paragraph sentence by sentence. You don't allow it to generate text. It's autoregressive. Errors are propagating. step number one, I'm giving the structure, every sentence that I want. I want to have 4 to 5 sentences, and every sentence will talk about this one. But I'm not sure that I had understood what exactly I wanted to talk about. So I'm asking, do you think the structure is okay? Let's see what it thinks. So it extends my structure, it extends what I have asked it to generate, and it elaborates. It builds on that, and when it builds on that, I'm using the same approach, and for every sentence, I get 4 candidates for every sentence. So then again, as with the titles, I'm taking each sentence, I'm comparing, and I'm building the structure on my own. And I'm also giving guidelines on my style, how I want the sentences to be generated. No fancy words, simple, semi-formal. I'm in control. I am telling it what to do, and then based on what it outputs, I'm the one making the selections. All right. Another example, few-shot learning. So few-shot learning is the most powerful prompting trick for large language models. In short, you provide an example, and you ask it to generate something based on your example. Let's see an example. So I'm teaching a class in a university about MLOps, Cloud for AI. And I want to generate a lot of question answers document for my students so they understand the topics, they get the questions and they question and they know the answer. But it would be very time consuming for me to get I have 20 different documents with then 10 questions and answers. What I do instead is I'm structuring my prompt like that. I adapt a persona. I'm going to talk about it later. So in some sense, it describes the context. I'm making it think that he's a machine learning professor at Stanford. So it imagines, it hallucinates that he has some knowledge. So I'm narrowing his search space. I'm defining the context, giving the task, and then I'm telling it, okay, these are 3 assignments that I have designed on my own. I want to follow this structure. I want you to cover these topics and to have these guidelines. And yeah, it generates the output. This is another example where we combine some of the tricks. First, you give the context as before, you describe the task. And in this example, I wanted to explain my students how neural networks work and how gradient boosted decision trees work, like random forest, XGBoost, and so on. So there is this great book by Cholet, Deep Learning with Python, that has this great example. And I'm like, yeah, I want something similar so the students understand it. And I'm giving the same example. I want something like that, a similar example, and so on. And I get this very good analogy, which I'm very proud of. So imagine you are solving a crime scene. Neural network is like Sherlock Holmes. He has seen 1,000 cases, so he has this abstract ability to think about the solution. And XGBoost is like weak learners, each one focused on a small task, and they are combining their opinions to get results. I really like this analogy. Another use case, keeping up with research. So last week it was the biggest machine learning conference. It had over 3,500 submissions. And yes, let's say we filter the papers that interest us based on keywords, forecasting, and so on. Do you have time to read them all? Of course, you never do, and of course you get tired even for looking at them. But what you can do is you can filter them down by having an LLM summarize. And yeah, there are some LLMs at the moment that are very good at summarizing text and having them talked over your PDF. It's a great tool and it works very good in my experience. And this is an example. So I'm uploading a document. I'm giving the context. You have read how many papers, so you can summarize them greatly. You get a paper, and I'm telling him I want exactly the structure, 2 paragraphs per section. So the paper was about using large language models for hyperparameter optimization. So it generates the output, and I'm asking further questions like, why do you believe, according to the authors, of course, why is their approach better than Bayesian optimization methods? And it generates an output. And then I came up with this research idea, why not combine LLMs for hyperparameter optimization and Bayesian optimization. I said, okay, what about this idea of having different LLMs pick different subspaces and then use grid space to search them and then combine them in an ensemble? Yeah, he says, okay, cool idea. Okay, create the blueprint for the experiment for me. And yeah, in like 5 minutes, I could test, not 5, let's say half an hour, I could test this approach and the idea. He got the code for me and I tested if it works. Another example, smart visualizations, they are very good at this. So we have a project and we want to cluster some companies based on some characteristics. And I want to have them in a single graph, which we have in the office. And every time we go, we pick whichever we want. How I will do that, I'm not giving the prompts one by one because it will take a lot of space. So the idea is again the same. You provide context, you give some general ideas. I'm explaining, I want to have a scatter plot. Each quadrant should be something. And what I ask is for it to have a hypothetical example. So he comes with a hypothetical example and we adjust on the hypothetical example. And just like that, we got a very good visualization about companies in Belgium. It's a step-by-step iteration. It generates something, I improve, it generates something else. All right, I need to, okay, let me speed up a bit. Research ideas, how to discuss research ideas. Okay, this is a very interesting one. LLMs are not able to reason. They are not able to extrapolate properly at the moment. They don't have very good generalization abilities. So if someone expects for it to come with creative ideas for new research directions, in my experience, it doesn't work because it stays on its training distribution. It interpolates over extrapolation. So it's actually me or anyone else that will come with a research idea. So what I have here is a fine-tuned LLM that I have explained which are my research focus and where I'm working at and what interests me and I have provided some papers to use as a guideline. So it has read these papers and it knows some stuff about my research. And when I have an idea, I'm going to it and I'm telling it, okay, contradict why my approach will not work based on literature. So instead of having it come up with a new idea, I am forcing a discussion with it that it will make me believe that my idea is not good, so I will improve my idea. And instead of expecting for it to magically give something, it's collaboration. It's very good at remembering a lot of papers and combining information. I'm better at creative thinking, so we work together for maybe one research idea might be a good paper. Next, we have coding. Okay, this is one of my favorite tweets. The hottest new programming language is English. Hot take, but yeah, in a few years that might be a reality. So I'm starting with Copilot, which I believe is the most used LLM product out there. And there is a survey saying that 80% of people on GitHub think they are more productive when they are using Copilot. So Copilot is an LLM trained on fine-tuned on coding tasks, and it's integrated into IDEs like Visual Studio Code. And while you are coding, you can have an inline comment, for example, functions that computes the average of the dataset, and it will create it instantly for you. Again, the same, implementing the function, it creates it instantly for you. Again, you just write what the function does, and it generates the function for you. So I'm coding a lot on my day-to-day tasks. And to be honest, since I started coding with Copilot, it's very hard for me to go back to coding without it, because you save a lot of time on going to Stack Overflow or how to make a very simple function like compute the average. You just say an inline comment and you have it ready right away. It's also good at translating functions. So there is this side project where we have a great R package, because R has some great implementation of many forecasting packages. Python has some advantages over R, so we try to get some packages and move them to Python. I'm not so good at R, I'm better on Python, so I want it to assist me. And again, I'm giving the context. I'm giving what the function does. I'm describing what the function does, and I am forcing it to think step by step, to split it into sub-problems, structure the search space for every sub-problem, and then explain what it does. And then I'm providing the R function, so we build it step by step. 2 tips. It's not working so well if you rush. It will make mistakes and you need to give the bugs and recreate them. And it's also very good at providing a whole repository from GitHub to give you suggestions on and explain code, complex code. Another example, boring and complex functions. So everyone has this string engineering that he has to do, where he has a big document that he needs to get rid of some words and so on. It's very boring to do it ad hoc with manual code lines. So yeah, I just say, just remove this, do this and do that. And it does that for me. Of course, I always verify because I don't trust it. We're gonna talk about it later. I'm gonna rush even more. The second one is complex visualization, which again, it's very helpful. So I'm giving this a CSV of some results of an experiment I'm running. And I'm telling him, okay, based on the format I have, visualize the RMSSE for some temporal levels. And this would take me probably, and then I'm changing the colors very easily. This would take me, I don't know, 10 to 15 minutes. But with this, it took me 1 minute to actually get that ready and throw it to the rest of my code. Extra stuff. You can get some LaTeX formula and provide the LaTeX code for that, which I find, again, very helpful. It can correct some vocabulary and grammar typos and mistakes, and it can create some picture for presentation. So this is an example where I was explaining Docker to my students. So it generated all this nice picture that says what is containerization and what its container does. However, one time, yeah, okay. These were some use cases. Now I'm gonna give some suggestions and some things to avoid. In my experience, when I had a lot of errors, it's all trial and error here. So we're starting with hallucination, which is the most important limitation of LLMs. And yeah, this is an example. So I'm just saying, are you familiar with global forecasting model? And of course he's not. He's saying something completely different. So it hallucinates, it creates something on its own. This is hallucination when it pictures stuff that is not real, but it outputs it like it's real. And what we should understand is hallucination for LLMs, it's not a bug, it's not a glitch on their code or on their functionality. It is actually, it's like that by design. So hallucinations are how LLMs are built. They are stochastic and they are autoregressive. So they sample from a probability distribution, they sample something, and based on that, autoregressively they build a document. So if something doesn't start right, if a small change in the initial tokens is wrong, then through error propagation, the whole document will be wrong. And this is what it is hallucination. They don't have reasoning abilities and they don't understand what is false. So if they start wrong, they will continue wrong. And given that this is a feature of LLMs and not a bug, we look for external solutions to solve hallucination. This is a recent paper from DeepMind in Nature. So they have an external evaluator that takes the output of the LLMs and it evaluates if it's wrong or not wrong, and then it updates a database of prompts. It's a feature. We cannot get away from hallucinations. We need to deal with them. And this is the most important advice. Never trust their output. Always, always, always verify if you're not 100% certain that the solution is correct. There are many cases. Here's the recent example where an attorney was suspending because he gave hallucinated cases. Always verify and always be on the driving seat. Like they have a very broad search space and they can sample from billions of, not billions, but thousands of tokens. So if you mitigate, if you try to shrink their search space by providing background, you'll get better results. And this is what I have been doing on all the examples. I'm trying to narrow down their search space so they don't go crazy and hallucinate crazy stuff. And also, if you force them to think step by step, you somehow mitigate the error propagation, because you build a structure in the beginning and they will follow the structure. So they will not go crazy. So thinking step by step, making them think step by step, and narrowing the search space are the best way to deal with hallucinations. Do not assume they read your mind, and I'm going to wrap it up. People assume that it's like magic and you ask them something and you get outputs. For example, what are the characteristics of global models? Yeah, okay, what are global models here? Like global models, there are global models in every research field. How do I know that you are talking about forecasting? Yeah, they don't know, they don't have common sense to understand that you are someone who does research in forecasting. So you want to have no global models in forecasting. They don't know your background. They don't know who you are. They don't know your style. They don't know how you want outputs. So be specific. And this is how I picture LLMs. I don't know if you have watched, it's one of my favorite series, Big Bang Theory. So an LLM is like Sheldon Cooper. You need to be specific. You cannot broadly go and ask him, tell me something. You need to very specifically ask what you want. Otherwise, you will get a very out of scope answer. And I have some prompt engineering tricks. First, write clear instructions. Don't do how do I add number in Excel, but yeah, go step by step. How do I add that, do that? I want to do this automatically, and details. Adapt a persona. When you're adapting a persona, they are structuring their search space, and there is literature evidence of how this works. I'm happy to provide it. Okay, discuss the challenges faced by startups. No, imagine you're a successful entrepreneur. Describe 3 common challenges. These suggestions are from OpenAI and they are public on their OpenAI platform. Number 3, specify the steps that will be used to solve the task. Summarize the code, like force you to think step by step. Summarize code, break into chunks, translate each chunk, and don't do it line by line as the output is similar. And there are some prompting methodologies in literature at the moment. The 2 most well-known is chain of thought. You just add, do I have it in an example somewhere? Yeah, you just add think step by step. And surprisingly, and it shows how little we know about these models, if you add this line, think step by step, there are multiple evidence that says that the performances get better. So this is a chain of thought methodology, and then there is the tree of thought, which is they self-evaluate and correct their output. So they generate a solution, and then you have another LLM that says, okay, this is the mistake you made here, and then this adjusts, and it's like a tree. It's like a tree, search tree. Okay, to wrap up, always work together. Do not trust what they are saying, and use them on cases where, in my experience, what I found working is when I'm using them in cases where I know the solution, but it's very hard to me to go to the solution. This is where they excel. They hallucinate it. Don't forget, narrow the search space. And yeah, I cannot stress that more. At the moment, it's hard to trust these models. Provide context and structure, and split into sub-problems. So the search space is more shrinked. And this is the last slide. It's a great tool. LLMs will get much, much better. They are here to stay, of course. So it's good to know how they work. It's good to know the advantages and the limitations. And of course, there is a middle ground between skepticism and productivity. Okay, I think that was most of it. Prompting style is very correlated with getting good results. So the better you prompt, the better the results you will get. Some extra references, and yeah, that was it. Sorry for the long talk, Anna.
Oh, no problem. That was amazing. I must say that I learned a lot. and especially with prompting and things like this. That was a fantastic presentation, and thank you, Philotas, again. Hopefully, people enjoyed this as well and found it useful. Again, check out our events and webinars and past webinars on YouTube, and see you around, and have a lovely Christmas, guys. Enjoy.